Welcome everyone to the RBD session of the Ceph Developer / Planning Summit for Squid. There is a link to the pad in the meeting chat with the topics that at least I have in mind. And I see there were a few more added. I think obviously the biggest item is, or the biggest bucket of work is RBD mirroring, and in particular snapshot-based mirroring. There are some fairly high priority, high impact bugs that need to be fixed, and they're still listed here, even though they are not feature work. It's things that we expect to take some time to fix. So like it's not a few hours of work for sure. And then further down, there are there are actual features proposed that I would like to spend more time on, since that's some discussion can definitely be had there. So I think I'll start by just quickly going through through these bugs at the top, and then we'll see perhaps something there needs to be discussed as well, and otherwise focus on features. And I also want to spend some time on non-RBD mirror related topics, obviously, since RBD is so much more than just snapshot-based mirroring. So with that, the first bug on the list is the data corruption that occurs when syncing, or that can occur when syncing cloned images. And the issue there is that if a copy up needs to be performed from the parent to the clone, then RBD mirror daemon on the secondary cluster does not do that. And if there is an object like a 4 megabyte chunk of data where there are some blocks that need to be copied up from the parent to preserve the obvious semantics, and then there are also some blocks that were modified in the snapshot that is being synced, then what happens is the blocks that need to be copied up just not, that just doesn't happen, and you get only partial diff applied to the secondary image, which from the user's point of view is just plain data corruption. There's a tracker ticket, and Nithya is going to be working on that. I don't think there's much more to say here, except that depending on how long this takes, and if this ends up, this is a fairly recent discovery. I think no one's hit it in the wild, just because not a lot of people are using snapshot-based mirroring, and cloning with snapshot-based mirroring is even more exotic, because you need to, for example, you need to enable mirroring on the parent image, and then it just, while it's a valid use case, I don't think it's come up yet, fortunately, and just depending on how long this takes, and what if how much work would be required, since the underlying issue is, or at least part of it is that the deep copy code, which is responsible for syncing, it has its own special kind of code path, and it does not use the bottom half of librd, which, if that were the case, would actually perform copy up just automatically. However, there are reasons for why deep copy is not using it, and so reconciling those requirements from coming from different sides might be somewhat tricky. So what I'm getting at is that we might just disable enabling mirroring, or in particular snapshot-based mirroring on images, on cloned images, for a while until the bug is fixed, and we're confident that there's nothing further resembling data corruption of any kind related to syncing clones. Moving on to the next item, syncing discards. There is a similar issue with syncing all object discards. Well, actually, not just all object, but also if the discard happens to be aligned at the end of the object. I believe it's also imperfect in that case. The reason it's not labeled with data corruption and just treated as a normal bug is that the user visible effect is that the space is not freed up, but as far as the contents of the image, while it is usually the case that discards in RBD zero data, that is configurable and generally should not be relied on, because it just you tweak a configuration file and end up with discards that are either unaligned or below a certain size threshold, just being ignored, and therefore, relying on discard changing the contents in a particular way, in this case zeroing, is just wrong, and that's why it's not labeled as a data corruption ticket, but it's similar in nature that the changes that involve discards are not synced correctly. It's just there are issues both with propagating discards and kind of applying them to the secondary image itself, as well as adjusting the object map of the secondary image to make that to make those discards be reflected in the disk usage output. The next bug is the propagation of block-listed errors between certain pieces of code in librd. This is a very old bug, and it's essentially an error path that is busted in the sense that it just swallows the error and does nothing with it. And previously didn't matter because block listing was more or less a fatal error, or a block listed in this case. This error code was fatal. But with the recent changes to allow for recovery from blocklisting, in particular in the mirror snapshot scheduler that is running in the manager, that code is working fine. It does its job, and it makes librd actually recover. Well, both the librd and the mirror snapshot scheduler. In most cases, recovery happens as expected, but there is an edge case where if the block listing is encountered, or in other words discovered, like if the first error, the first block listed error is comes out of a particular set of methods, then a particular error path is invoked, and since the error is essentially discarded, the recovery from blocklisting just stalls, because we hang deep in librd in the call stack that's supposed to just be exited from. Ramana is working on that. That's a fairly high priority issue because the user visible effect is that replication just stops. That's because we hang in librd, that in turn hangs the mirror snapshot scheduler if it because it can no longer take snapshots or mirror snapshots on the schedule, and with no mirror snapshots taken, nothing is getting synced. So from the user's point of view, replication just stops. Moving on, a related but very much orthogonal item is that while looking at these blocklisting issues and analyzing the various occurrences, I realized that the kernel client can block list excessively, and there is a fairly simple change that can be made to make it be less trigger happy when it comes to block listing. Again, previously didn't matter because block listing is that's supposed to be or that was supposed to be a fatal error. But now, again, with mirror snapshot scheduler actually recovering, and generally with the way the mirror snapshot scheduler operates, where it opens a bunch of images, takes snapshots on those images in quick succession, and then closes them. This can confuse the blocklisting logic in the kernel client somewhat, and the end result would be that it would blocklist the mirror snapshot scheduler when the right course of action would have been to just back off and retry the operation that triggered the blocklisting. Whatever it is, it might just be just the workload attempting to write to the image. It doesn't matter what that operation is. What matters is that if the kernel client is not holding a lock and then ends up needing to acquire it, it just needs to be more careful with the data that it's looking at before it makes the decision to blocklist. I have a patch for that ready. It's I think it's code complete. Just um, need to test it, and should land upstream in a matter of a week, maybe two. Moving on, the next item is the force promote. Here it's worded as getting rid of the various preconditions for that, and of course the major one is that force promote currently requires or currently waits for the imagery player in the RBD mirror daemon to back off, or in other words, to if the snapshot is getting synced, then it essentially ends up waiting for that sync to complete, which is contrary to the definition of force. Force promote should be immediate, or at the very least, bounded in time. It should not be waiting for something that can actually never complete, because if in the course of syncing that snapshot, the primary cluster suffers from a disaster, then we basically just hang indefinitely. This is a very ugly failure mode, and this item was actually there in the plan for Reef, but didn't get completed, and was moved to Squid. And if I'm being honest, we are probably not going to complete it in full in Squid either. There is a fairly simple workaround, which is perfectly fine, at least for when an actual disaster occurs. What the user needs to do is they need to shut down the RBD mirror daemon. Can be just killed, nothing special. Then perform force promote on all images that suffer from a disaster, and restart the RBD mirror daemon. It doesn't even need to be restarted immediately. Technically, it needs to be restarted only after the cluster that experienced the disaster comes back to life, or a new cluster is added as a peer, to reestablish mirroring in the opposite direction. So with that workaround in mind, this still remains to be a very ugly issue, but it's not as high priority as many of these other things. There are other use cases for force promoting. In particular, the one that I've been educated about is just testing force promoting on a cluster which is shared, so which is multi-tenant cluster, where a particular tenant is interested in they have a set of RBD images, and they're interested in testing both ordinary promote and force promote on those images, because they want to see how their application would react to that. They want an end-to-end test as part of their perhaps regular DR checks, which is a good thing to have, just like regular backups need to be checked. DR setups need to be subjected to the same level of scrutiny. And in that case, shutting down RBD mirror daemon, which is not per tenant, it is a global daemon. That is obviously very, very inconvenient and needs to be coordinated with other tenants, or just random downtime would occur. So that's why that's why the workaround is not sufficient. And Shyam, you have a comment?
Yes, the secondary image testing or validation from a force promote perspective. The other option which I added a little down the line in the same notepad is to actually just clone from a mirror snapshot, so that you don't really need to force promote the current image, but the application is interested in knowing if it uses the last snapshot that was mirrored as its primary data. Does it have any, does it still recover? Does it have any other issues? So if you could even clone the last mirrors, one of the mirror snapshots in the past, and provide that as a volume for validation of the application on the secondary side, maybe an option instead of having to force promote for validation in this discussion. Did that make sense, Ilya?
Yes, it does, and I think that's actually supported. So you can clone from a non-primary image or from a non-primary snapshot, and that should cover that use case. The force promote still comes. It's still needed. Like when an actual disaster occurs, that's how you move the workload to the secondary image, because if all you have is a clone, then technically that's a separate image. And while you could, when either the cluster that experienced the disaster is back online, or you've peered an entirely fresh cluster, you could just start working with that clone. That's not. I think that's less ideal, because that's an extra image with its own name. It needs to be orchestrated and all that. So force promote is still important, but as far as the use case that you brought up for cloning from a mirror snapshot, or I should say from a non-primary mirror snapshot, for validation purposes, that there is some provision for that in the code already. Not sure how well that works. It's certainly not something that we test, but that's something that I think it's at least partially there, and we should. I think we should just take a deeper look at that and run some tests, and perhaps no additional work would even be needed to support that use case, at least in Ceph, right? You would still need to orchestrate for that in ODF, but in Ceph that might already be working.
Got it. Understood. Yeah. So yeah. Right.
All right. So the next item is give up if the source cluster, if the primary cluster becomes unavailable.
Ilya, can I interrupt for a second? It
Sure.
just was on the same lines that Shyam was sharing, but the IO path, like the reads or the snap list that we are doing from the secondary cluster and the primary cluster completely goes down, will still be in a stuck position, right? As of now, even without even involving the force promote. Should that be addressed? I mean, like, even if you try to do a clone and as Sam suggested, right? Even if you go with that approach, the ops will still be in stuck state for the previous image, isn't it?
No. The clone is meant to. Shyam is, at least my understanding is that he is bringing it up as just something that would be used for validation purposes, where the user just wants to get access to the most recent synced snapshot and check whether the application can be restarted based off of that snapshot without actually disrupting your application, without without promoting the image, and
That is right.
potentially without even without disrupting the application whatsoever. Just have a second copy of the application started on the secondary cluster from that snapshot and see if that checkpoint is recoverable. And there everything is working, and I mean a clone it's even though it's a clone, it's still a clone that is local to the secondary cluster. So even if the primary cluster goes away at that exact moment, you are still going to like that clone, even though it's cloned from a non-primary snapshot, it is still local to the secondary cluster, so all reads would still work. But then
yes. Sorry, I was just agreeing with you, Ilya. I'm sorry, because yes, that's exactly what I meant.
Yeah, I actually understand that point, but if you are like, what happens to the copy operations that are run by secondary cluster towards the primary cluster for reading the for reads as part of the actual image?
The reads would not go to the primary cluster. That's why I'm saying that the clone there would be local to the secondary cluster, because as part of there is well, let me so if the cluster is completely if the primary cluster goes away entirely, then that might still be an issue, but that's not a use case that we're targeting here.
Yeah, I actually get that point, Ilya. What I was trying to say is even before the primary cluster went down, there would have been snapshots scheduled between the primary and the secondary, right? So those, the copy of the snapshots are happening from primary to secondary. While this is happening, just in case if the primary cluster goes down, even before we are trying to clone the image, right? So the reads which are in progress are still in stuck position, right? So what are we going to do with that?
The reads are in stuck position. I'm not sure. I think you're confusing the reads that would be issued by the application using this clone, and the reads whatever reads that are being issued by RBD mirror daemon at that point. RBD mirror daemon is going to be reading something, and yes, that's going to hang.
Yeah.
But the application would be reading from this clone. The clone is based on a snapshot, and that snapshot had already been synced. Otherwise, the clone the clone would not be, or at least should not be allowed to be created.
Right. Yeah, exactly. So the issue that we are trying to solve here are to cancel the reads that are being issued from the RBD mirror, right? Application reads comes next, but
no, application reads are completely disjoint from RBD mirror daemon reads.
Yes. Yes.
And yeah, so I think we are just in the interest of time, we should table this, because
sure.
That's again, first of all, that's not a use case that is being targeted by this by this item, and second, I think there is just some misunderstanding as to which reads would come from where. But the next item, which is giving up if the source cluster becomes unavailable, that's very much related to this, and related to force promote to some extent. So I mentioned that what currently happens is if RBD mirror daemon is syncing a snapshot, and the primary cluster disappears, then the image replayer, like for that image within the RBD mirror daemon would just hang. And since there is typically at least in current setups, or we have a single pool with a bunch of images in it, that pretty much translates to that entire pool getting stuck, which again makes sense if the cluster is if the primary cluster is gone, then it doesn't matter how many pools you had there. But just from the perspective of RBD mirror daemon, like the whole daemon would get stuck. And the way this is being tackled is we are going to be employing a timeout at the latest level on all operations that need to go via the intercluster link. So operations that are targeted at the opposite cluster. There are some challenges there similar to the propagation of the blocklisted error, which I mentioned earlier. Only in this case, this would be timeout errors, and this is going to trigger a bunch of error paths that were either completely untested or very lightly tested by some limited unit tests. And Prasanna is working on some synthetic timeout error injection to get those issues hammered out. And once that's done, I think we're going to enable timeouts by default for everything that has to do with the opposite cluster. And finally, there is this is kind of my pet peeve. We have a growing backlog of integration tests, which get deprioritized due to high priority bugs coming in. I've listed here two tracker tickets. One is the first one, I think. Well, one of them is an integration test for latency or high latency, to be precise, injected between the clusters, because we've hit a major bug with that scenario where, due to some unfortunate interaction of the kernel client and the RBD mirror daemon, well, the kernel client on the primary cluster, the one that is driving the user's workloads, and RBD mirror daemon on the secondary cluster, and the exclusive locks between them. These three things could interact in a pretty bad way, with the exclusive lock effectively needing to bounce between these clusters over the high latency over the high latency link, and that could produce multi-minute or even dozen-minute stalls for replication on the images involved. That was fixed, but the like a proper kind of full-scale integration test for that was tabled, and similarly there is another integration test which needs to be ironed out because and adjusted for the nuances of the topology environment. And this one is for replicating the data corruption bug exactly the way that it was discovered. And this, what I'm referring to, is the snapshot object map corruption, which I fixed a few weeks ago, which could lead to again data corruption in the in secondary images. With my fix, I've included a very comprehensive integration test that does not involve snapshot-based mirroring, because the bug actually had nothing to do with snapshot-based mirroring. It was more generic than that. But we also want to include a test that would cover this snapshot-based mirroring scenario, because believe it or not, despite this scenario, and namely a file system on top of a block device served by the kernel client, despite that scenario being the primary scenario, at least on the ODF side, we don't have a test for it in the RBD test suite. So that definitely needs to be introduced with some varying facets. So I have some ideas as far as kind of expanding it, growing on the same, like essentially using the same work unit, but scheduling it with different configuration options and different pool configurations, etc. I think that this completes the kind of the RBD mirror bugs section, and the next the next set of items here are RBD mirror feature requests. With the first one being snapshot-based mirroring of consistency groups. This was there in the Reef on the list for Reef. It was always a stretch goal, and I think it's going to remain to be a stretch goal for Squid. I don't think there's much to discuss here, because the semantics, like the latest news there is that the current semantics of RBD consistency groups as they exist today might be sufficient for what is needed, at least by ODF, and that leaves indeed just mirroring those groups of images. Previously, it was believed that the consistency groups themselves would need extensive work before they're even suitable for for any kind of serious use. But I think I'm still confused about the kind of the consistency model that we want to kind of adhere to, or the model that would be sufficient for the use cases that are being targeted. But that deserves a whole other 1 hour meeting at least. So I'm going to stop here. The next one is a performance improvement to resync split brain images from a common ancestor snapshot. And I think what is meant here specifically is resyncing after an image is force promoted, resyncing back to the cluster that is, if the cluster that experienced a disaster is brought back online, Resyncing back is currently equivalent to just re-enabling mirroring from scratch, which is obviously means that the entire data set is resynced. I'm not sure if a common ancestor snapshot can be kind of identified and maintained reliably, and even if we did that, if we could safely use it as a common ground point. The reason the images are resynced from scratch is that once split brain occurs, we know nothing about that image, and so even if there still is a snapshot with the name that we expect, we don't know what else happened to the image. In particular, the user could have created some non-mirror snapshots on that image, which would not be correctly synced because the deep copy code would know nothing about them, since technically they are more recent than this common ancestor snapshot. And I think there might be other edge cases with that. So this is definitely a kind of an exploration item. Implementing it just head on is likely going to lead to another data corruption popping up in the future. So I would be very cautious here. But that's something that we can at least kind of think about. I don't think anything is going to happen in the Squid timeframe here, but just keeping this in the back of our heads would be good. Staggering replication schedules is the next performance improvement. I believe that refers to so currently the way Mirror Snapshot Scheduler works is if you configure, for example, a 15-minute schedule and you have 100 images, then it's going to schedule that 100 images for 15-minute intervals that would roughly correspond to, let's say, the top of the hour, the quarter into the hour, and and so on. And I think the complaint is essentially that there is a period of time where the primary cluster is going to really busy taking snapshots, and that with exclusive log balancing from the kernel client to the mirror snapshot scheduler, and then a period when, after those snapshots are taken for the remainder of these 15 minutes, if the cluster is well tuned and well suited for the workloads that it's serving, then that should take a minute, maybe a minute and a half. And so for the remainder, like 13 or 14 minutes, no snapshots are taken, and that introduces variability and spikes in the various workload graphs. So I think they ask us to kind of evenly spread the schedules across the intervals, at least in the most simplest case when there was just one interval, or maybe there was there are two or several group of images, but for each group of images there's only one interval. That should be doable, and something that I think can be in scope for Squid. I'm not sure if that's actually if that's an actual performance improvement, because again, if the cluster is well, like if the cluster is not overloaded, then taking snapshots, even if you're taking like 100 of them in very quick succession, that's not an operation that that should disrupt anything. But still, I think reducing this irregularity is probably good. Shyam?
Couple of adding a couple of more points there. Yes, agree that we don't know whether this will improve performance in any particular way or something. Second thing is, would it be correct to say if we staggered the creation of the snapshots, it will also stagger the secondary pulling in the delta from the primary?
Yes, but only if these deltas are tiny, because if the delta takes a while to sync, then if there's images if the images in a group that has a let's say a 15-minute interval are staggered on a by-minute basis, so there is like 1/15th scheduled for each minute in the interval. Then if the sync takes longer than a minute, or by default, we limit the number of concurrent syncs to, I believe, 5 to avoid overloading the primary cluster with, a storm of reads from the RBD mirror daemon. Then, with those two constraints combined, what would happen is the syncs would just get delayed, and then it doesn't matter when the snapshot is taken because the syncs would proceed at their own, quote unquote schedule as allowed by the sync throttler and by the, by the syncs actually completing.
Got it. Yeah, if the sync takes time, it's going to overlap or get throttle a future sync of another snapshot. Yeah, but otherwise, in general, like if I had everything within a minute and 4 snapshots in a minute, and then think, if everything lines up, let's say 5 images, and then it should just get staggered. If you just stagger the snapshot schedule, the remote RBD mirror daemon, secondary RBD mirror daemon should ideally pick it up in those staggered schedules by default,
right?
Based on these constraints. Yeah. Okay. Got it. No, that's useful because then we kind of, if we tweak around with these parameters, we can play with the bandwidth usage being more constant over time. Let's call it that. It won't be constant, but at least spread out over time.
Yeah, that's exactly what I'm referring to as like variability or irregularity, right? Getting rid of that and allowing the user to actually have some control and to be able to tweak this. And just in general, like if you look at the pretty much any graph, whether it's the number of snapshots taken per minute or the IOPS for your workloads, assuming like let's say your cluster is overloaded, then you would definitely see the IOPS like the spikes when a bunch of snapshots are taken because exclusive locks are going to start bouncing, and spreading that in time is I think is useful. Yeah. So again, not so much a performance gain, but just kind of reducing these irregularities and giving users more control. I think that's the goal here.
And just adding to the point that just in case if we can keep monitor on the copy time that it is going to take, right? The sync time that it's going to take for an image, or take giving some hints like that. With that, like probably a user may be able to set the schedule in that way.
Well, we do that. We are actually reporting the time that it took to sync the last snapshot. Very, it's very visible. It's reported directly in the image status JSON. So user can, and then of course the users would probably not look at those dumps, especially if they have a lot of images. But that's where the Prometheus-based metrics come into play, which are being worked on. and they're based on exactly the same, on exactly the same source of information, on exactly the same fields. And that way, I think users would interact with Prometheus dashboards a lot more than with image status command and its output that is pretty hard to make sense of, to be honest.
Yeah. So if you can play well with all these numbers, right, the reported numbers, I think like staggering the replication intervals would be useful feature.
Well, staggering would happen automatically irrespective of these numbers, right? We would just like, this would be based on just, third grade arithmetic, right? You just take a group of images, there's an interval, you divide that interval by, in chunks, and then just check that, because there might be other groups of images with other intervals, and just, then normalize for other groups of images with overlapping intervals, and that should be it. I expect this logic to be local to the mirror snapshot scheduler. It wouldn't need to take inputs from the image status or any other places. It could just be handled, completely in isolation without looking at anything at all, other than the set of images and the set of schedules.
Yeah, agree.
All right, moving on. I think we've covered cloning from the last holistic snapshot. And then the last item on the performance improvements list, streaming snapshot deltas kind of in advance, instead of doing this on a per object basis. So instead of reading computing delta for a particular object, reading it, and then applying it before moving to the next object, I think what this is referring to is, attempting to do this for a group of objects, or even for the entire snapshot, like for the entire image, and syncing that cumulative delta, and then applying it on the secondary cluster. I'm not sure that's going to result in any performance gains at all, but I'm willing to be persuaded otherwise. And regardless, that's definitely not happening in Squid, because this is going to change the entire kind of deep copy logic, deep copy state machine, which is also used in other places. So right now, the benefit is that like snapshot-based mirroring is basically reusing a large swath of code, which is used for other things in RBD, for example, for migration, as well as just pure deep copy of an image from, let's say, one pool to another. This is how you can, for example, change the parameters of your image. So if you want to change the stripe pattern, or you want to move it from being replicated to being erasure coded, that's how you do it, and it's the same code that's responsible for it. Doing something, implementing something special for snapshot-based mirroring is not something that we want to do.
I agree, Leah. And with the intention of this is to keep the network busy. But if there are ways to do that by staggering the schedules, increasing the parallel images, then I think as long as we're network bound, we're okay. Bandwidth, network latency, and bandwidth bound.
Yeah, I understand what you're saying. It's not so much the bandwidth, it's the latency, because if we expect the latency to be, in the tens of milliseconds and up to, I think we discussed 100 milliseconds, then that is like that latency needs to be traversed an awful lot, right? It's not just a delay of 100 milliseconds. That latency is getting traversed over and over again. And that slows down things considerably. So the bandwidth is, at that latency, the bandwidth is probably not going to be, we're not going to be bounded by the bandwidth, we're just going to be bounded by the available bandwidth at that latency. So the network is always going to be undersaturated, I'm afraid. But it's a function of latency, not of anything that we can do at the RBD level or the Ceph level.
we can move on. Yeah.
All right. Well, I think fortunately we're almost out of time. But so I'll quickly go through the non-RBD mirror items. So there are a few that were scheduled for Reef, but got moved out. Related to migration, in particular, life migration from non-Ceph sources. The main item on the list of these changes, which we have PRs for, which have been lingering there for a while, waiting for reviews, is support for so-called RBD stream. And what this is about is adding the ability to live migrate from an RBD server, so from something that is kind of backed by RBD to an RBD image, and have it be live, and the added benefit here is that the proposed change also preserves the sparseness of the image, and the primary target here is QCOW2 images. So picking that up and importing that in Ceph while the virtual machine is running. That's kind of the high-level goal. There are a bunch of details as to how it's implemented and why it is not using the existing support for QCOW2 format that we have in RBD. But I'll spare those details. The main message here is that this is targeted for Squid, along with the supporting and kind of further life migration improvements, which are listed down below. This is also adding support for migrating using the support that we already have in Ceph. So not the new RBD stream, but using what already exists in Ceph, but extending that to cover multiple, to cover migrating between Ceph clusters. The way the code that is being referred to here today works is you can migrate, for example, between the different pools of the same cluster. So like I mentioned, you can move the image without disrupting the workload. You can move it from being replicated to being erasure coded, for example, but you can do this across Ceph clusters. One of the PRs on this list is targeting that. And then there are a couple of bugs related to how migration interacts with support for native encryption that was added in the Pacific release, and then extended in the Reef release to support cloning use cases. There is if you throw in live migration in the mix, it just it just doesn't interact at all, and this is something that we need to fix. The next bucket is Windows support, or support for the or improving support for RBD, for natively mapping RBD images on Windows. This is achieved by the Windows NBD driver and or Windows NBD daemon. And there are at least two major improvements proposed by the cloud-based team. Support for persistent reservations, SCSI persistent reservations, to enable the Windows clustering use cases, and in particular CSVs, cluster shared volumes. There is a pull request which I have some reservations about, as far as the kind of the data safety, and as far as how these reservations are actually enforced, and the race conditions that might that the current proposal is prone to. The intent is to start discussing this early in the Squid release, and hopefully get this landed in Squid. And then the next improvement is multiplexing multiple Windows NBD mappings into a single RBD WNBD daemon, so that there's only one daemon per host. The goal here is conserving resources, because the way it's currently operating is you get a single instance per mapping, and that translates to a separate set of sockets, a separate set of various types of resources, but sockets in particular that are being allocated for each mapping, and that's suboptimal. The same happens for the Linux NBD driver. So these drivers are currently on par with each other, but for the Windows driver, there is a proposed change to make it optionally multiplex to, like I said, conserve resources on Windows host. And then Radoslav was here, but unfortunately left. There is an interesting limitation that is enforced by Rebus OSD cap semantics, which I think would be good to look at in Squid. This is a low priority, but it's just, I don't think it's going to take a lot of work, or at least we could start working on it. And this is basically if the user wants to enforce, or if the administrator wants to enforce read-only access for a particular tenant or for a particular user at the OSD capabilities level, then there is an RBD read-only profile that they can use for that. But unfortunately, that profile also disallows watches from being established. on the image. And that's because watch operation is considered write on the Rados side due to the fact that it is actually persistent some metadata in Rados. So technically it's a write operation, but semantically it's not like nothing is actually, like semantically, at least at the RBD level, nothing is actually written, and therefore we lose the ability to get notifications and, for example, detect that the image has been resized. So if there is a read-only mapping, but someone resizes the image, then that mapping does not get notified about that, and since it's read-only, it's not going to write. It's not going to be allowed to write bogus data to the cluster, but still the user experience is suboptimal. I've already discussed this with Sam though, and I think we are in agreement that this is something that we could make a small tweak for in Rados to make the watch operation not be treated as a write for the purposes of read-onliness or kind of enforcing read-onliness at the RSD caps level. But then we would also need to, once that's in place, do some adjustments in RBD, since this is a long-standing behavior. It just recently came up, and I got reminded about it. And finally, there are some tweaks to the QA suite on top of the integration test backlog, which I mentioned for RBD Mirror. We have some outstanding work items there. Migration to Ceph ADM, as well as I think, and again, I would like Slav to comment on this. I want to drop the cache steering jobs from the RBD suite, because most of them just fail, and I end up approving those failures. I don't think there are any plans to dedicate any resources on the Rados side to improve cache steering. And so just making that official and dropping those test cases, I think is the way to go. And with that, we're over time, but I wanted to run down the entire list so that since the meeting is recorded, folks can watch at their own leisure. Any questions, any comments, any topics that are not on the list that folks think should be there? Sounds like no. In that case, thanks everyone, and I'll see you in the channels.
Thanks, Ilya.
Thank you.
Thanks, everybody.